Okay, so we've been talking about probability and specifically how to represent it either using a segmented bar graph, a two-way table, or a Venn diagram, as well as our formulaic representations using the probability rules. So today we're going to look at an example of some FRQs you might see on the AP Stat exam. And the goal here is just to introduce you into the ways that we communicate the math, specifically in the notation and then the writing. Because for the purposes of the AP exam, you need to communicate what you're doing before you do the math. So first off, we have this two-way table, which gives us the information about what graduating class the participant was in, or what they did after they graduated. So I'm actually going to say something like this. Let the variables be as follows. And this just helps me for communicating to my reader that these variables represent the respective category here, right? Because I'm looking at categorical data because all of this data represents the frequency of these occurrences here. So let the variables be as follows. 1968 is a class number from 1968, C for college, etc. Okay, so the first type of probability we have here says, what is the probability? Oh, and I almost forgot my most important part. Can't just willy-nilly add things. I need to actually make some total columns. So I'm going to add in everything from this two-way table. So this T here just represents totals. So my total number of numbers of 1968 was 221, and the total numbers of 1998 was 292. Again, I have 513 numbers in the sample, so if I add those two values together, they'll sum to 513. There were 229 individuals who went to college, 135 who pursued a job, 122 who went to the military, and 27 who had some other type of plan. So now that I have these total frequencies here, I can actually use this in my probability model. So the probability that a randomly selected attendee graduated in 1998 and went into the military, we write this notation as follows. So I look at 1998, and then it's an and problem, so I'm going to have an intersection that they went into the military. We go here to the table, and we look for the group that was in the military in 1998, which would be 37 individuals out of the 513 individuals in this sample. You can just leave it as that fraction. You don't even have to simplify. But for aesthetic purposes, if you do decide to go with the decimal representation, we're going to round to 4 decimal places, and we still need to ensure that our fraction is on the paper. Okay, next up, it says, what is the probability that a randomly selected graduate graduated in 1968? So I'm going to take this probability that they went to school and graduated in 1968, again, using my total columns here. That's just going to be 221 individuals out of 513, which would approximately be about, let's see, in this sample, that's going to be about 43.08% of individuals. Again, notice that I have my fraction, and then I have the decimal approximation. So this is just a notation. Part 1 is a joint probability. Part 2 is a total probability. Okay, so I'm going to go ahead and erase this now because I'm recording in my empty classroom. And I'm going to go on to the next few questions here. Again, more rules of probability. Yay. So in question 3, it says, what is the probability that a randomly selected attendee did not pursue the military after graduation? And notice there is a key phrase there is this little did not. So what needs to happen here is that since I'm looking for the people who did not go into the military, I can just write it as follows. This means the complement of the military. So if M is the event they went into the military, MC would be the event they did not go into the military, which is what I want. I'm going to take 1 because that represents my total sample space, and I'm going to look at the individuals that went into the military. Well, that would be 122 individuals out of the 513, which would give me the following result. Out of 513 individuals, it appears as though, and I'm typing away here, it appears as though 391 of those individuals did not go into the military. And as an approximation, this will be about 0.7622. Excellent. So let's go on to 4 here. So 1 was a joint, 2 was a total, 3 was a complement. Now 4, we have a union probability. So I want the probability that someone went to school, they graduated in 1998, or they went to college after graduation. So you have one of two things you can do. You can add up the you can add up the members of 1998 and then the one other group for the college. You can pull those values, those frequencies directly from the two-way table, or because this is the general addition rule, we can actually just sub and solve. When we have the or, we have the following events A and B minus the intersection of both. Now notice it's not A and B here, I actually have some context. But I can just use this formula to find the total number, and then I'll verify with the two-way table. So the total members in 1998 would be 292. The total members who went to college would be 229. And the total amount that went to college and were a part of the 1998 class would be 173. So again, I divide that by 513. And when I do this, it appears as though the total amount of people that either went to school or went to college would be, oops, I'll accidentally put a plus, would be 348 individuals out of 513. And again, as an approximation, this is about 0.6784. So that's one way. That's using the probability rule. If you want to, though, you can just add the frequencies from the table. So for example, we know there's 292 people who went to college, who were in the class of 1998, which only leaves us the class of 1968, but of the class of 1968, only 56 of them went to college. So if I do 292 plus 56, that gives me the same 348 individuals that either went to college or graduated in the class of 1998. All right, next up, 5 and 6. These are the weird ones that we have not yet talked about, but we briefly mentioned them in the trash can ball activity. These are the conditional probabilities. And so I'm going to just introduce some quick notation here. This here is how we represent a conditional. This means the probability of A, and this bar here means given B. We have a whole series of lessons on this for next week, so don't worry about notation. For 5 and 6 for now, I just want you to worry about the value, and then next week we'll introduce the notation for it. So, for example here, it says, what is the probability that a randomly selected attendee graduated in 1968, given that they immediately pursued a job after graduation? Actually, for 5 and 6, I'm going to take this back up to the table, and I'm going to show you how we obtain those values. Okay, so on question 5 again, it says, what is the probability that a randomly selected attendee in 1968, given that they immediately pursued a job after graduation? Okay, so my conditional here is given that they pursued a job. So I'm looking at this group here, and the total number of people who had a job would be 135. Okay, so from those 135 people, I'm looking at the probability that they graduated in 1968, which would be this 73. So I'm ignoring the other events here. So for question 5, what I'm looking at is just the number of people out of a job who graduated in the class of 1968. So that's actually just 73 out of 135. Now there's ways to write this notation, but again, we'll introduce that next week. The goal here is just that you're able to recognize the differences there. And then on question 6, it says, what is the probability that a randomly selected attendee pursued a job after graduation, given that they graduated in 1968? Okay, so now I'm actually changing my conditional here. Remember, the total amount of people that graduated in 1968 was 221. So now instead of looking at just the job category, now I'm looking at 1968. So I'm just specifically zooming into these 221 numbers. From there, I'm looking at the amount of people that had a job from the class of 1968 here. So for number 6, I'm looking at this group of 73 individuals who had a job and they were a member of the class of 1968 out of the 221 individuals that were a member of the class of 1968. So that's just the differences there. And one, we look at the column, right? In question 5, we were looking at the column, whereas in question 6, we were looking at the row. And notice question 7 says, what's the difference between 5 and 6? Well, in question 5, our condition was that they had a job, whereas in question 6 was the condition was that they were a member of the class of 1968. So that's just a little brief overview on how we use a two-way table to find probabilities and the ways we use notation here. So just as a refresher, 1 was a joint probability, 2 was a total probability, 3 was a complement, 4 was the union, 5 and 6 were both conditionals. So that's just, again, a brief overview on some probability rules.